Hi everyone, welcome or welcome back. I am Thomas Willingham and I'm here with Christopher Chapman.
What's up?
Say hi, Christopher.
Hi.
Okay. We are here, networking fundamentals. Oh, bam, I lost my Vanna whiteness. Networking fundamentals, and we're here to talk about defining network infrastructure and security.
Yep.
The objectives, so our skills and concepts that we will learn, understanding networks outside of the LAN, local area network, and understand security devices and zones. So, let's talk about the Internet. Amazingly enough, the Internet is a worldwide system of connected computer network devices that connect to the Internet, use the TCP/IP protocol suite. The Internet contains a lot of information, resources, and services, including World Wide Web, servers hosting content. Now, some people use Internet and World Wide Web interchangeably. The Internet is the overall infrastructure. The World Wide Web is a service provided on the Internet.
Correct. I was happy on this one to include the very descriptive diagram. Very helpful.
Well, I mean, honestly, that is a standard graphic.
It is.
So when you see cloud, you typically think Internet, unless you're talking about cloud infrastructure.
Unless you're talking about the cloud. So we've gone so long learning Internet as the cloud that now we're going to add cloud to it to make it more complicated. So.
Correct. Internet also has supporting infrastructure for email and connectivity for peer-to-peer networks. So we talked about the Internet and World Wide Web being one of the services provided on the Internet. It's a system of interlinked hypertext documents that can be accessed using a web browser. Interlinked hypertext documents can contain text, graphics, videos, a variety of content. Currently, we refer to the World Wide Web as World Wide Web 2.0. This refers to the social aspect of the web. So as it's become more social in nature with Facebook and Twitter and things of that nature, we've entered what we refer to as Web 2.0. It's a more interactive version of the web. Web 1.0 was more, I'm browsing the web, I'm looking at web pages. It was more static.
Like a broadcast.
Like a broadcast, exactly. Versus the Web 2.0 is a lot more dynamic. A lot more exchanging of ideas, the interactivity, and again, the social aspect of the web.
That is a giant one.
Intranet. So we have the Internet, which is the global or external network. Intranet is a private computer network. So normally within a company, they will have an intranet or single website that an organization implements in order to share data with employees around the world. Typically, for intranet access, user authentication is necessary before a person can access the information. What this does is use of username and passwords, keeps the general public out, and allows people who need access to the information access, people who don't need information, it keeps them out. The extranet is basically the external facing or the external portion of a network. So the intranet is the internal facing, extranet is external facing. So it might be used for like partners or groups that work with the company but aren't necessarily in the company. User authentication would still be necessary, but again, the extranet is not open to the general public. So to access company data, there's a couple different methods. One is the Intranet for internal employees. Second's the extranet for partners. And then the third is the web, web servers for the general public. So basically we have the different versions here. So there's partner, there's public, and there's remote users. So partner, they would use the extranet. Public, they might use web services. And remote users might use an intranet. VPN, Virtual Private Network, is a connection between two or more computers or devices that are not on the same private network, that basically have a private conversation. In order to ensure that only the proper users and data sessions cross to a VPN device, data encapsulation and encryption is used. A tunnel is created from the client to the server through the LANs and WANs that are being used. So at that point, the LAN and WAN are just vehicles that this tunnel uses. Popular VPN protocols include PPTP, point-to-point tunneling protocol. This encapsulates point-to-point frames, PPP frames, into IP datagrams for transmission over an IP-based network. By default, the data is not encrypted in a PPTP session. So normally, or additionally, an encryption method such as MS-CHAP is used to encrypt data within the datagram. There's also LTTP or L2TP/IPsec. This is a combination of PPTP and layer 2 forwarding, L2F, put out by Cisco. Again, we're back into a whole bunch of acronyms here. The PPTP and layer 2 forwarding, L2TP, is used for the tunneling. IPsec is used to encrypt the data. So this is a little bit more secure than straight PPTP. Point-to-point tunneling protocol allows multi-protocol traffic to be encrypted and then encapsulated in an IP header sent across an IP network or a public network. They can be used for remote access and site-to-site VPN connections. It uses a TCP connection for tunnel management and a modified version of generic routing encapsulation, GRE, to encapsulate PPP frames. The payload of the encapsulated PPP frame can be encrypted, compressed, or both, but PPTP doesn't do this. You would need to use a different protocol to encapsulate that protocol. And then in the graphic, we see a example of what the frame might look like. So the IP header, the GRE header, and then the PPP frame. Again, if it's actually encrypted, it's encrypted using an additional protocol. That's the benefit of L2TP with IPsec, is it includes data encryption and encapsulation. So again, allows multi-protocol traffic to be encrypted and then sent over any medium that supports point-to-point datagram delivery. L2TP relies on IPsec in transport mode for encryption services. And encapsulation for the L2TP IPsec packet consists of two layers. The first layer is L2TP encapsulation, so the PPP frame is wrapped with an L2TP and UDP header, so that represents that top frame. And then the IPsec encapsulation, so the L2TP message is wrapped with an IPsec encapsulation security payload, ESP, header, and trailer, and an IPsec authentication trailer. So let me do this here really quick. So
while you're doing that, I'll inject a little note. These details we're doing for the advantage of people learning the information, learning how these technologies work, and especially in this case, what encapsulation is, taking the existing packet, wrapping it in some additional information. But this detail is probably beyond what you'll need, say, for the certification. It's probably beyond what you need really in implementing these technologies. You need to know a lot about the technologies, but you need to know more about the interfaces for implementing them, L2TP, PPTP, and IPsec, the components within Windows clients and servers to implement them, more so than the packets themselves. We figured it'd be good information anyways.
Plus, it's just plain fun. This is fun. So look at, you're taking this packet right here that has an IP header, UDP header, L2TP header, the PPP header, and then the payload that at this point is not encrypted. You're adding the ESP header, the L2, oh no, that's already there. So you're adding the IPsec ESP header, the trailer, you're encrypting this payload, and then also adding an IPsec authorization trailer. So this is basically what the packet encapsulation and encryption looks like. You start up here with this packet, and then that gets encrypted and encapsulated in this packet here.